Hi, this is Lakshmi Kantiwari. In this lesson, I'm going to start a very new video series on a deep learning. So in the very first lesson, I'm going to start a deep learning with TensorFlow 2.0. Okay, so the TensorFlow 2.0 recently it has been launched by the Google, and the Google has promised so many so many advantages of a TensorFlow 2.0 over a TensorFlow 1.x. So this we will be learning. Initially we will be learning just an introduction of TensorFlow and how and why we should use TensorFlow 2.0, and then we will be working with the MNIST dataset throughout this tutorial, and then I'll show you how you can import the MNIST dataset, and then after that I'll show you how you can do some data exploration, and after that I'll show you how you can build a model with TensorFlow 2.0 and the Keras with the high level APIs. And then finally how you can compile, and then how you can train your model. The maximum training accuracy is 91%, and the testing accuracy is 88%, which shows that the model is overfitting somehow. Okay, so this will be the all in this lesson. Before I start this lesson, I would like to tell you one more thing. You can go ahead at my channel KGP Talkie, and at the KGP Talkie I have made so many videos. I have basically made on the 3 basic topics. The first topic was Python getting started. So there I have covered the pandas, NumPy, matplotlib, seaborn, data visualization. And then the second part of the lessons was on a classical machine learning, like linear regression, logistic regression, KNN, SVM, decision tree, random forest, PCA, ensemble learning, etc. and the learning curve. And then the third was based on a feature selection. So I have selected the feature based on the filter methods, wrapper methods, and the embedded methods, as well as with the linear discriminator analysis and the principal component analysis. Okay, now come back to this lesson. Without wasting a time, let's go ahead and start a brand new lesson on a TensorFlow 2.0. Since this is a very short and a quick lesson on a TensorFlow 2.0, so I'm going to take a very quickly a theory part, then I'll start a coding on this. So once we start the TensorFlow, the first come in our mind, what is the TensorFlow, right? So currently the TensorFlow is the most famous deep learning library in the world, and it is developed by Google. The Google product uses machine learning in all of its product to improve the search engine, translation, image captionings, recommendations. Moreover, the Google does all these things to improve the user experience, right? So this TensorFlow architecture works in the 3 parts. The first, it pre-processes the data, then it builds the model, and then finally train and estimate the model. That's mean it train the model and then evaluate the performance of the model, right? And it is called the TensorFlow because it takes input as a multidimensional array, which is also known as a tensor. That's why it is known as a TensorFlow. Now very quickly, let's go ahead why every data scientist learns TensorFlow 2.x. Currently the Google has released the TensorFlow 2.0, the RC version, which is the release candidate, and why we should leave a TensorFlow 1.x. There are so many things which Google has changed into a TensorFlow 2.0. Okay, so the TensorFlow 2.0 make the users more productive, including the removing the redundant APIs and making APIs more consistent. The TensorFlow 1.x has many APIs, and the most of them were the redundant, and the many times users get confused, the data scientists get confused, which is the best way and how to use those APIs to get the better accuracy. That means we had some, let's say, the particular task, and for that particular task there were so many APIs, and the data scientists were getting confused which API will be the best for their the data and for their model. So in TensorFlow 2.0, the Google has deprecated and removed all those APIs. So moreover, the Google has done the API cleanup, and it has uses the eager execution, which is a Pythonic based, moreover, and it improves the execution time. And while defining the variables, now in the TensorFlow 2.0, it doesn't use any of the global variables. And the TensorFlow 2.0 has also removed the sessions. The earlier in TensorFlow, we had to use the session.run. And now the TensorFlow 2.0 is kind of bringing it like a function call. And moreover, now the TensorFlow 2.x or 2.0 brings the Keras at the core of the TensorFlow, which ultimately increases the improves the accuracy. uh, that actually can increase the accuracy, but that is not 100% sure that increase the accuracy. But moreover, it reduced the training and the testing time, since the Keras has been integrated with the core of the TensorFlow. And in that case, its execution will be the faster actually, and it also takes a less space, and moreover it is the consistent. And if you want to know more about the TensorFlow 2.0, what it is offering, you can go ahead and visit this link. It has a Google I/O link there, and at the Google I/O you can see this, the complete, the getting started with the TensorFlow 2.0 at the Google I/O. So there Google has released this TensorFlow 2.0, and they have covered almost everything what is the new in the TensorFlow 2.0. Right, there are so many things the new into the TensorFlow 2.0. Although this is the new video series, and we will be learning a lot about the TensorFlow 2.0 throughout this video series. Now let's go ahead very quickly, and I'm assuming that you have already installed the Anaconda and other necessary libraries. Only you need to install the TensorFlow. And if you do remember the previously, you need to install the Keras and the TensorFlow separately. But here you only need to install the TensorFlow. You actually don't need to install the Keras. So you can call the pip install TensorFlow equal to the 2.0 RC, and you can go ahead to this GitHub link where you can get the TensorFlow the release. Okay, so here we have a TensorFlow 2.0, and you can visit that. I think with this, yes. So here we have the latest TensorFlow, the 2. This one is not the latest one. Although with the website, if you go and visit on the website, there you will get a latest one. The TensorFlow 2.0, the release candidate is available, and you just go ahead there. You will get the link here to install this. So you can keep monitoring this link to get the updated version. By the time I'm making this video, this is the latest version. Now let's go ahead and open Anaconda into administrator mode. Remember, you need to open it into the administrator mode. Otherwise, it would not be able to install the TensorFlow 2.0 in your computer because of the write permission. Now let's go ahead and copy this, which I can just copy it, and in the Anaconda, by pressing the right click, it will paste here the pip install TensorFlow equal to 2.0.0 RC0, that is the release candidate 0. Let's go ahead and hit the enter. Although I have already installed the TensorFlow 2.0, that's why it is saying that the all the requirement has been already satisfied. But if you do not have the TensorFlow 2.0 installed in your computer, you can install. And moreover, if you get any error, then you can first uninstall the previous TensorFlow. For that, you can write there pip uninstall TensorFlow. So it will uninstall your previous versions, and then you can install a new version of a TensorFlow. Okay, perfect. Now let's go ahead and see if you have a GPU in your computer, then you can also install a GPU version of a TensorFlow. Right, so these are the two ways where you can install a TensorFlow in your computer. Now you can pause the video and pause this video, and you can continue this video after installing the TensorFlow 2.0. Alright, now let's go ahead, import the fashion MNIST dataset. So in this lesson, we will be working on the fashion MNIST dataset. The fashion MNIST dataset, the link is available here, and this working working file is available in the video description from where you can download. And if you visit this fashion MNIST, then you see here on the GitHub, the link is available, and on the GitHub it says that this is Zelando's article images. It has 60,000 examples, and every example have 28 cross 28 grayscale images. And so these are the images, and it has 10, actually it has the total, the 10 classes, and that's mean there are 10 type of the fashion images are available in this fashion MNIST dataset. Okay, so these are the images which are the available, and these 60,000 images which we will be using to train, and 10,000 images to we will be using to evaluate, and it has total the 10 categories of these images. Okay, now let's go ahead and first import our now first let's go ahead and import the TensorFlow, and then I'll show you how you can download this the MNIST dataset directly into your Jupyter notebook instead of downloading it from a GitHub. Okay, perfect. To import the TensorFlow, you need to write there the import, and then the TensorFlow. There we have a TensorFlow as usual, TensorFlow as TF, and then we need to import the Keras from the TensorFlow. So here we have a from TensorFlow import the Keras. Okay, so now we have got we have got the TensorFlow and the Keras. This A. Now we have imported the Keras from a TensorFlow. Now let's go ahead and import other necessary libraries like NumPy, Pandas, and the Matplotlib. So those things we can say that a helper library. But before that, let's go ahead and check a TensorFlow version, which you can just check from a print tf dot version. So this says that we have a version 2.0 installed in my computer. Now let's go ahead and import helper libraries like NumPy, Pandas, and the Matplotlib. So in the previous videos, we have been importing these libraries very frequently. NumPy as np, and import Pandas as pd, and then import matplotlib.pyplot as plt. So here we have Matplotlib, the Pandas, and the NumPy imported in our computer. So these things we can treat as a helper libraries. Now let's go ahead and load the MNIST fashion dataset. So for that, I can write here the MNIST is equal to the Keras dot datasets, and then I can write there the fashion MNIST. So with this, we will get a fashion MNIST dataset, although I have already downloaded it in my computer. Otherwise, it might take a little time in your computer to download this dataset from a internet. That might take a few seconds if you have a fast internet. Now let's go ahead and check the type of the MNIST. This says that with this MNIST, actually it has downloaded a datasets in a TensorFlow module wrapper. Now what we need to do, now we need to actually load the data. Now we need to load this data into a real variables in this Jupyter notebook. And to do that, it actually returns a tuple. Okay, the two tuples, one tuple for the training and another tuple for the testing. So for this, what we can do here, the MNIST dot a load dataset. As usual, we have been doing into sklearn. Now in this tuple, we need to first get the data into our the training dataset, that is the X train, and then finally Y train. And the next tuple, in the next it returns the testing datasets. It has X underscore test and then Y underscore test. So it has a 60,000 rows for a training, which we can verify that with xtrain.shape. Now there you see here, there are 60,000 images are available there, and each images have 28 cross 28 Since there are 60,000 images, that's mean it should have a 60,000 Y train as well. So let's go ahead and check the shape of Y train, which says that it has a 60,000. Okay, now let's go ahead and print the X train and see what happens. Once we print the X train, we see the values, the most of the values are printing here 0. That is because, at the edges, since this is the grayscale, so at the edges, the most of the images values are the 0. Otherwise, the maximum value inside this, the array, which we can find that with np.max. Okay, so that is the 255. So the minimum we have already seen there, and that is the 0, but here the max is 255. And if we see the average, that's mean the np dot mean the X train. So it says that something. So moreover, now we can say that the values is somewhere in between 0 and the 255. Okay, inside this data set, which later we need to bring down in between 0 and 1 to train with the TensorFlow model. Okay, our deep learning model. And these 60,000 images are classified into 10 labels, and those labels are encoded into a numerical values, and those numerical values we can see with the y underscore train, and those numerical values are in between 0 and 1, sorry, 0 and 9. Okay, so it starts from the 0 until the 9, so those are the 10 categories there. Now let's go ahead and write those category names, although you can get on the Fashion MNIST those category names there. You should get those category names somewhere here. Yes, so these category names are here. Okay, so these are the t-shirt, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, and the ankle boot. Now let's go ahead and write that the class names here, so that we can write in a new variable the class name, and inside those class name we need to write, okay, the t-shirts and the top, etc. Like here we have, let's go at the top, and the another one we have here a trouser, and then here we have the pullover, and then here we have a dress, then we have a coat, and then finally we have the sandal, and then we have a shirt, and then we have a sneaker, and then after that we have a bag, sorry, it's bag actually, not a bed, and then we have ankle boot. So these are the 10 classes, right? Now let's go ahead and do some the data exploration. So with this data exploration, we can actually understand our data in more explored way. Okay, so since we already have seen its the shape, etc. So here if we see the x underscore the train dot shape, we have 60,000 images, but if we see here x underscore test dot shape, there we see we have just 10,000 images. So this 60,000 images is available for a training, and this 10,000 images is available for a testing purpose, so that we can test our model and we can see how accurate our model is performing. Now let's go ahead and visualize the data, some images, so we can visualize that with the PLT. So here we have a PLT dot figure, and then we have a PLT dot image show, that's the IM show, and inside that we are gonna the see first image, okay, that is the X train 0, and then I'm gonna just see it, and now you will see here it has this image. Okay, so this is actually the boot. Okay, and how would you know this is a boot? And if we print here the X train, actually there you see it's 9 number, and at the 9 number you see here we have an ankle boot. Okay, so this is the boot, and if we see here 1 number, and now you see at the 1 number it's a 0, and at the 0 it is a top. Okay, so this is how we can visualize. And if we print here a color bar at the side, okay, so we can just write there the color bar. Okay, so with the color bar, now you see we have here a color bar, and in this color bar now you see the value is somewhere in between 0 and the 255. Since neural network model doesn't take the value greater than the 1, that's mean we need to bring down the value, the maximum value, the 255, in between somewhere 0 and 1. So what we can do to bring it down, we can just divide the value with the 255. I mean the training and the testing data set with the 255. So we can get here with the x underscore train dot x underscore train is equal to x underscore train, and then divided by 255.0. Okay, perfect. All right, so we have got the x train in between 0 and the 1, and similarly let's go ahead and bring the x test in between 0 and 1, which we can get by dividing x test by a 255.0. So with this we have got our x train and the x test in between in between the 0 to 25. And what we can do, we can just copy it, although you need to use your keyboard Control and the C, and let's go ahead and paste it here and see what happens now. Now with this you can see here we have brought it down in between 0 and 1. Okay, so now this value is now ready to feed into a neural network. And one more thing, you might here notice that this size, size is 28 cross 28. That's mean there are 28 pixels, and these are the pixels which you can see. Okay, so these are the pixels, a square dot there. So these are the 28 dots here and the 28s here. Okay, perfect. Now let's go ahead, now build a model, a machine learning model with the TensorFlow 2.0. with the TF 2.0. Okay, so in this, what we are going to do, the basic building blocks in any neural network is a neural network layers. Okay, so the layer extracts the representation from the data, and then it fade into its a hidden layer actually, and then finally it starts the training. Okay, so although this is the very quick lessons on the TensorFlow 2.0, and I'm assuming that you know a little about the neural network. So basically you understand how the neural network works. So let's go ahead and import the sequential and the dense model, sequential and the dense layers from TensorFlow Keras. To do that, what we can do, from the TensorFlow dot the Keras, import sequential, and then from TensorFlow dot Keras and then dot layers, import from here I'm gonna import the flattened layer that will be used as a first layer, and then dense layer. So we have got the two layer, and flatten and the dense and the sequential model. Now let's go ahead and create our model. So here we are going to build our model with a sequential model. So here we have a sequential, and then we are going to pass here an array. Okay, so the array means the how many the layers we need inside our sequential model. There are many ways to build this, but I think this is the simplest way, where we can add all these together. Otherwise, there are a few other ways, like just defining first sequential and then going with the model.add. we can go ahead with that one as well, like model.add, and then we can add there the first flatten layer there, and inside the flatten layer the input, the shape, okay, which we are gonna use here. Input shape will be the 28 cross 28 there. Okay, so this is the input shape for our the flatten layer. The flatten layer doesn't do anything actually, it just transform the formats of this data, which is 28 cross to 28. So this layer just transform this data into a one dimensional so that we can fit into a next layer. Okay, so the next layer which I'm gonna add here, the model dot add, that is a dense layer. Okay, so this is just a dense layer, and inside the dense layer, if you press here shift and double tap, you will get here a detailed documentation on it. So in this, I'm gonna pass the number of units, that's mean the number of nodes, how many the neurons actually we want, and then we will pass here the activation function, which activation function we are gonna use. I'll be taking a different lessons where I'll be covering all these things in a very detail. This is a very quick lesson, so I'm not going to cover all those things here in the detail. So activations we will be using, and other things we will be just passing as usual. Okay, so other things will be like other things will be a default actually. So here in the dense layer, I'm going to pass here the 128 neurons at the first layer, and the activation function which we had talked there, that I'm going to use here a ReLU activation. So this is kind of the rectifier, the activation function. There are so many other kind of activation function like a sigmoid, tanh, and you know, the ReLU, leaky ReLU, all those. So here for this lesson, I'm just going to use a ReLU, and then the model dot add, and then again I'm going to use the output layer. In an output layer, if you add output layer, then we need to define the how many outputs are there. That's mean the total number of classes. We have 10 classes. That's mean we have to define here the 10, and the activation function here. So at the output, the ReLU activation function activation cannot be used. So there at the output, either we can use a sigmoid or a softmax. So here we are gonna use a softmax. Okay, so here we have a model. Now let's go ahead and print the summary of this model, and then you might understand how it is building. So the first model has transformed a two-dimensional data into a single dimensional, and then here we have 128 neurons. So 128 and then multiplied by that 784, its complexity reaches the number of parameters actually then reaches to these digits. Okay, so that is the 100,000s, and then finally at the output we are bringing it down to the 10. Okay, just a 10. So we have number of parameters at the final output to calculate is the 1290. Okay, so the total parameter which this model will be executing is more than 100,000. Okay, so this is how we build the model. Now we need to compile our model. Okay, so for compilation of the model, there are a few things which are really very important. Okay, the first which we need to actually define, we need to convert it into a markdown. Yes, so the first thing which we need to define is a loss function. Okay, model compilation. So to compile the model, we need to define the loss function, which loss function we want here, and then we want optimizer. Okay, and then after optimizer, we want here metrics. So what are these things? A loss function, it will measure how accurate the model is during the training and testing then. Okay, actually the loss function minimize the overall error during the training, and once the error is minimized during the training, then the testing error will be also minimized. But that is not always the true, because sometimes what happens if your model overfit, then the overall loss get minimized during the training, but during the testing it get increased. So here the generalization of model is very important. That's where optimizer comes. So this is how model is updated based on the data. That's mean the weights of our model gets updated with the as we define the optimizer. Now let's go ahead and compile this model first. So we can compile this with the model dot the compile, and then here we have optimizer is equal to Adam, and then here we have a loss function there. A loss is equal to sparse categorical. Okay, so there we have sparse and categorical cross entropy. Okay, and then finally here we have a matrix, and inside this matrix we have accuracy. Okay, perfect. Now let's go ahead and run this, and once we run this, so it's of course it has compiled there. Now let's go ahead and train the model. For training a model, it is really very simple, as we have been doing into our sklearn library. There we have a model dot fit, and then here we have x underscore train, and then here we have y underscore train, and then finally here we have a total number of epochs, okay, is equal to 10. So with this, once we write this, it will start showing a progress bar during the training. So the first time, at the first epoch itself, the accuracy has increased to 82. Now the epoch means at the first time the the weights get initialized randomly, and when model moves to the second epoch, then by a back propagation it updates the model. That's mean what it is doing, at the 10 times it is updating the models, and then it is running on whole data and each epoch. Okay, that's mean if I define here epochs is equal to the 10, then that's when this model is getting trained 10 times on a whole data. That's mean the weights are getting updated 10 times on a whole data. Now let's go ahead and finally evaluate the accuracy of a model. How we can evaluate the accuracy? To evaluate the accuracy, the TensorFlow has inbuilt model.evaluate, but in this beta version that is not working very precisely. That's mean, let's say if I write here a test loss, and then the test accuracy is equal to model.evaluate. Okay, so there it has x underscore test and then y underscore test. Okay, and then if we print here the test accuracy, let's go ahead and see how much test accuracy we will get here. So this is a kind of, there is a problem, I think, perhaps that's why it is showing these random things, although this will take some time, just around 10 to 20 seconds, and then it gets completed, and then finally it will show us total accuracy on a test set. Okay, now you see here the test accuracy on test set has been shown at the end of this. That says that the 88.75% of the accuracy at the test, and the total loss is 0.25. Now you see here during the training our accuracy was 91%, and at the testing time accuracy is 88%. That shows that the overfitting of our model. So this is kind of a very simple neural network model, just a single layer. Just a single layer is there, just a single hidden layer with the 128 neurons. So we can expect that this much of the accuracy with this. Although if we use CNN and other networks on this, then we can get a better accuracy. Okay, and on the GitHub it is claimed that with the CNN we can get around the 99% accuracy. In some other lessons we will be also learning it with the CNN as well. Now let's go ahead and do the prediction with the Now let's go ahead and do the prediction with the sklearn as well. Okay, so what we can do here with from sklearn dot metrics, and then here we have import accuracy score. Okay, so now what we have here accuracy, now we need to first get the y pred as well, so that we can get here y pred is equal to the model dot predict. Okay, now you see here we have the two classes actually, the predict and the predict classes, and the predict probability. So the predict will predict a set of the array that will be the continuous value, but we need a predict classes. So with the predict classes we can get actually what is the predicted class instead of a continuous value on a test data set, that is X test. And then finally let's go ahead and bring it with the accuracy score, that here we have y underscore test, and then here we have y underscore pred. So now you see we have got the accuracy of 88.75%, which we have got with the model.evaluate. Although I think there is some bug in this current version of the TensorFlow, that's why these things were coming. Okay, perfect. Now let's go ahead and make a prediction on just some random the random test image on just a single image separately, and then we will stop this lesson. Okay, to do that what we can do, we can just write there, let's go ahead with the pred with the model dot a simple predict, and then finally we have here X underscore test. Now if we print here the pred, so the pred is kind of a continuous array. That's why I had not done with the predict only, that's why I had used here the predict classes. And if you see there the y pred here is continuous, it's categorical value actually, that's in the classes. Okay, so with this now let's go ahead. One thing you see, the class has been predicted, the first class has been predicted, the 9, and if you see here the first array, the continuous value, now you see here at the 9th one, okay, that's in the 10th class, 10th number at the 9th index, at the 10th index, that's mean 0, it starts from the 0, that's mean here 9. So it says that at the 98%, with the confidence of the 98% that it is the 9th. Okay, what we can do now, we can pred here at the 0 value. Now with this you can see it very clearly. Okay, so this is the maximum at the 9th place. So that how we can do. We can do with the argmax here. Okay, so here we have np.argmax, that's mean the maximum argument at which place there. So that's the pred 0. At the pred 0 you see the maximum argument at the 0th location, and similarly we can bring this the maximum prediction at the first location as well. Okay, so at the first location the maximum is the argument 2. Okay, perfect. So this is the way how we work with the TensorFlow 2.0. This is all about in this lesson. Please don't forget to like this video and subscribe this channel so that you can get updates directly into your inbox. In further lessons, I'll be also covering more videos on TensorFlow and deep learning. Till then, bye bye and keep learning.